My name's Ezekiel Keator. I am a software engineer at PayPal. I work specifically on checkout. Today I'm going to talk a little bit about feature flags, specifically framework-agnostic feature flags. We started rewriting checkout about 2 years ago, and we have a lot of different feature flag solutions in all different applications at PayPal. Even within checkout, we have multiple different ways to handle feature flags in the legacy checkout applications. So while rewriting checkout, one of my goals was, how can we create a feature flag solution that can be used across multiple applications, not just in checkout, but across PayPal? And in order to do that, we need to create something that is framework agnostic, because not every team is going to use the same framework. How many people here currently use a feature flag solution at work? Okay, looks like the majority do, so we can probably skip through this slide pretty quickly. High level, feature flags allow you to enable and disable code in real time without doing a deployment. They allow you to do gradual rollouts, do like a 1% traffic check, see how many of these users are experiencing errors. Is there an increased amount of errors before you proceed with a higher ramp? Or you can cancel the ramp. You can also do A/B testing, see did A or B perform better, and choose the winning solution. They significantly simplify application development because you can create a feature flag early, continue to merge commits behind that feature flag. You as a developer can experience those feature changes by enabling your flag, and your product and design teams can also experience those by enabling that feature flag. And they encapsulate all the feature eligibility logic, so you don't have a bunch of if statements with a whole bunch of different conditional checks spread all throughout your application. Why build a new one if there's so many that already exist? Almost everybody here raised their hand. A lot of these solutions today do most of these things, but not all of them. And what really struggled for us was the strong typings out of all of these the most. So a lot of feature flag solutions today take in a generic string type, right? So that string type doesn't really give you any verification. Does this feature exist in my system? It also doesn't allow you to discover what features exist in the system. So you may go to some sort of global feature store. You may go to an external system like LaunchDarkly and see like, okay, what exists? What should I call? And when you make a mistake, like a typo, nothing's going to catch that for you at runtime, or compile time rather. We also need support for wide range frameworks, and we need end-to-end testing. This was a big one for us. So end-to-end testing can be done in most of these other solutions today, but it's a little bit up to you. Or they want you to tightly integrate with them. They may say, OK, make an API call to us. We'll give you this special cookie or this special header. Now you can use this, and you'll be set in this allocation. But what happens when you need to do that across a whole bunch of different feature flags? It gets complex, and usually you're kind of on your own. And finally, the multiple data sources is really important to us because we need to support app config. We need to support an experimentation platform that's internal. We are testing external application experimentation frameworks. And in order to support all these things, we don't want to have like 3 different ways to define a feature flag, right? We want one solution. And when we move between feature flag systems, so for example, our internal one to maybe an external one, we don't want to have to do a bunch of refactor work, rewrite all the feature flag logic, and change the entire SDK out. We also want to be able to gradually move between them. So you may have a feature flag defined in the new system, and you have 10 in the old system. Well, some of those ABs, you might just let them run their course in the old system, and when the winter comes and you delete the code, that's fine, you'll be moving them to the new one. And then you might have some long-lived ones that you'll gradually move over to the new system. Creating a new flag is very simple, and it follows closely, inspired by the API from the flags module. We had a call with Dominic about 1.5 years ago, before the flags module existed. At that time, the flags module had no license file. It was pretty skimpy on docs, but we absolutely loved what we saw. We loved the API. There was a big but, though. It only worked with Next.js and Svelte. That might work for some of our applications, but less than 1% of them. We have a lot of JavaScript services. Some are just APIs, not even web interfaces. So when we set out to create this new thing, we decided to take a lot from what we saw with that to create this nice API where creating a flag is just creating a function. And the reason is a new developer joins PayPal, and they just see this and they kind of understand it, right? This is just JavaScript. You're not thinking, OK, I got to go learn this specific data provider and figure out how do I define a flag and any of that. No, it's just read the code and you kind of understand it as a JavaScript engineer. Calling these flags is really simple. It's just a method call. You don't have to pass anything into it. And because it's a method call, you can jump to function definition and see the entire decision logic. So you don't need to go to a global store and search, OK, what is this feature flag name? It's very easy to infer the types. So you notice down here, we don't have a string response type of variant. We have a string literal union. We know exactly it's v1, v2, or experimental. That makes conditional logic, doing if statements, switch statements, much simpler. And it means if we're using TypeScript, we're going to get an error if we didn't handle something correctly. Another thing we enhanced on top of this was adding context. And this was not in the original version of the module. Context allows you to pass in some data at the very beginning of your request handling. This data is typically something that's already resolved, so like your application config, maybe some user data from a JWT, but it should never be something that takes a long time to resolve, because you want to attach this as early as you can in your request handling process, so you don't want to do any blocking work. You need to have it attached before you can resolve a feature flag. So anything you put before this means you can't do feature flagging work in that. So typically, I recommend this is attached at the very beginning, or at least within the first couple of whatever your middleware-like chain looks like in your server. The context is also helpful for emitting logging and analytics, because that context object gets passed through when we'll look in a bit the logging. So we support almost every framework out there. Pretty much, the caveat is if you don't work with async local storage, you have to create your own storage solution. But thankfully, almost everything works with async local storage today. And this enables all the teams at PayPal to use whatever runtime and whatever framework they want to use. The async local store is responsible for handling caching and deduplication. So you can call the same function over and over within the same request, and it's actually only ever going to resolve once. So if we have a synchronous flag, we're going to call the side method, and we're going to store the result in the cache. If you have an asynchronous flag, we're going to call the promise, and we're going to store the promise in the cache, and we're going to return the promise. That way we don't block anything. And if you call that flag from multiple other locations in your application, you're going to get that promise back. We don't care if it's been settled yet or not. Your code is responsible for awaiting it. Because of that, we avoid latency with multiple repeat calls. So when we're rendering something like the checkout page, we can check for a theme feature in the header, the body, the footer. Instead of doing prop drilling or passing it around in all these different method calls, we could just import the feature function wherever we're directly going to use it, call it. We don't need to think and worry about what's the performance hit of calling this in multiple locations. Because there's a cache, we also export utilities for pre-populating the cache. This underpins almost everything related to the utilities that you're going to see on how we handle testing and how we do feature propagation across microservices and all of our dev tools. So when you attach the store, you can pass in an entire populated cache if you want, or you can individually work with the cache like this, where you can just set a specific result. And when something's in the cache, the decide method never gets called, so you're essentially short-circuiting your feature flag. A big thing that we did was code generation. And before people who don't like magic get their pitchforks out, it is absolutely optional, and it has zero impact on runtime, even when you're using it. The code generation is primarily built for improving developer experience and developer tooling. It leverages the OXC crate in Rust to parse the AST. Originally, we were using JavaScript, and I think we were around like a second, and that was only like 30 flags. Today, we're up to about 90, and we're able to generate those in less than 80 milliseconds on a Mac M1. And right now, checkout is only just starting to ramp this new experience to international. And so as we expand out to all the countries we support, this is going to exponentially explode in the number of flags. During code generation, we generate tsdoc out of that description method that you may have noticed in the earlier flag definition we did. And we detect duplicate flag definitions and key collisions. So that means if you've defined a flag multiple times in your application with the same key, we would have an issue in the cache. So we're going to catch that at the code generation time. The code generation outputs 3 artifacts by default. This can be extended with adapters. Those 3 artifacts are for CSpell, JSON, and TypeScript currently, and they're all optional. The CSpell is if you use CSpell in your project to help catch spelling mistakes, it creates a dictionary based off everything that is in the configuration of your flag. So if you have acronyms or anything else that might not be a valid word, you don't need to add these CSpell ignores all over your project. The JSON is primarily for interacting with developer tools or other services that may want to know what features exist in this application, because JSON is easy to use with any other language or other application. TypeScript is primarily meant for consumption within your application. It does export the whole config, which can, again, can be used in DevTools. But more importantly, down here at the bottom, notice that we do this type generation, and we do a declaration merge on the feature flags. Specifically, that interface flags. We have the key of each flag and the value of each flag with tsdoc injection of the description method. Code generation can be configured. This, again, is optional. We apply a lot of defaults that we think just make sense. But if you want to fine-tune it, you can pick what you include, what you ignore, where you want to output everything. Adapters. Adapters allow you to actually hook into the AST parsing and create custom outputs. So this is where if you want to actually code generate real source code that gets executed, not just these static artifacts, you can do that here. Or you can create custom adapters that do code generation even for TypeScript typings for your special feature flag adapters, which we'll talk about in a second. And then you can control the outputs, and the outputs can be extended by the adapters. So if you add a new adapter that outputs something, it will now be typed within your outputs. Because we're using code generation, we can and encourage our developers to do co-location of feature flags with code. And what that means is, don't have one global file with all of it. You can do that if that's what you like, because you control the configuration. But this makes feature flags very easy to discover, easy to maintain because the files are smaller, reduces Git merge conflicts, and if you're doing monorepo caching, it frequently helps reduce cache busts, because if you have one big feature flag file across your monorepo, every time you adjust the feature flag, you're probably going to bust most of the cache across your monorepo. Adapters, there's two forms of adapters. We have adapters that are simple wrappers around flags that automate the creation of a feature flag. This is the most common form of adapter. That type of adapter is meant to connect to things like launch darkly, post hog. These type of adapters create a decide internally, pass that down into a flag, and then the flag returns a flag function back up. The other type of adapter works code generation. If you're doing a lot of custom logic inside your adapter that's talking to a data provider, there's a good chance then you might want to create one for the AST code gen side if you want strong typings. At PayPal, it took approximately 120 lines of code to check an experiment and log to analytics. That now takes 6 lines for a flag configuration. Of course, not everyone's going to write 120 lines over and over again when you have, nearly 100 features. But that meant every team was recreating patterns on how are we going to call experimentation, how do we want to do analytics. So this adapter allows us to solve it once. The adapters on a high level are a simple wrapper around a function. So that means our PayPal custom adapter calls a decide method, creates a decide method, calls the base flag, we get back to the flag function. When the flag is resolved, it runs the custom decide method. So in this case, we check for an AB of a user. We log the result to analytics, and we have to return a flag result. That's the strict typing if you're using TypeScript to make sure you don't make a mistake. Here's what one of our custom adapters looks like, the ramp flag. The experiment and resource name are two things that our internal experimentation system needs to understand what experiment and what application am I targeting. Treatment names is what treatments are inside this experiment. We also have another flag that's for simple Booleans. In this example, we're looking at something where we're ramping and comparing multiple experiences for a user to see which performs better. Default value is used if there is either an error while resolving this flag, or if there is no treatment returned, or if a treatment is returned outside of the defined treatments. The reason for this is it guarantees you the response from your adapter, this ramp flag, is going to be one of those treatments. It's impossible for it not to be. An error, I'm getting default. Outside of what I've defined, I'm getting default. Unit testing. How many times have we seen multiple ways to mock the exact same thing in a repo? And then how many times have we been frustrated and just gone and copied what somebody else did to mock something? So providing a first-class developer experience, I believe, requires providing utilities like this out of the box. So we provide a method that mocks the feature flag store. Everything you're seeing here are optional. The first object is defining the feature itself and what value to resolve it to. Mock mode tells the system, do not resolve any of the flags, just return default value. Short circuit every flag in the system, give me a controlled state. I will tell you what to turn to what state to override it. And then context obviously lets us mock the context. Here's an example where we start to write a unit test. And so we can see that we have strong typings here that's giving us autocomplete in our IDE, letting us know what features exist that we can mock. And we can even see that there's already a hint there on the right that, OK, here's the values it's going to be, and it's optional. And further to the right, we can see there's the TS-doc. So we know what is the purpose of this flag key without even going and looking up this feature flag, which is especially useful when you're doing testing where you don't see the flag definition in front of you. After we fill in the flag key, further, our editor is letting us know, OK, here's the values it can be. And if you're using TypeScript, all of this is being validated by TypeScript. But even if you're not using TypeScript in your repo, you get this autocomplete in almost all editors, assuming you have TypeScript support installed into your editor. When somebody deletes a feature flag from the system, we can enforce cleanup across all of our testing because the feature flag no longer exists with code generation runs. So it's going to give us errors in our repo and say, this has to be deleted and cleaned up because the feature flag no longer exists. The PR that removed the feature flag will never pass CI unless all of the tests have been cleaned up. Similar for end-to-end testing, but it's a little different because end-to-end testing typically starts with an external process. So we spawn something like a browser. The browser needs to open the application, needs to do some interactions, and assert some stuff. Because of that, we don't have this shared state that we can pass and override the feature flags. We're in a whole separate process. Yeah, we could do some kind of internal process communication, but that wouldn't be persistent across different services at PayPal or refreshes or going between, say, like a stage application that then redirects you to some other test DNV application, because redirects do happen for things like authentication. So what we've decided to use is cookies. We set a cookie with a feature flag override, and we set that mock mode. So that mock mode forces the entire checkout application into that default state. All features are off, and now we toggle on just the ones we want to run end-to-end tests for. This is especially important if you have some kind of side effect. For example, say there's one feature that redirects a user to an add card page if the card on file is expired. Your other end-to-end tests that expected to see the review your payment page would all start failing. So by turning that off, that feature can exist and be being ramped, but our other end-to-end tests don't break. And we only have to sort that out after the experiments have run their course, and the person who deletes that can do the cleanup. The end-to-end tests can also pass overrides to downstream services. There's a little bit of a caveat here. The downstream services have to be implementing this module as well. And we have to have a way to pass it to them. The easiest is you could just forward that cookie when you're in your test environment to your downstream service calls, but you can also do it any way you want. If you want to pass a header, you want to send query params, want to use an external memory cache, it really doesn't matter because you have control over how to pre-populate cache. What I'm showing you here is what we've built and just a default utility that we're providing with it. Custom logging and error handling, because at PayPal, we log to multiple endpoints. For example, when a flag resolves, I need to log to analytics, and I need to push to Datadog RUM. When an error happens, I also need to be able to get the error and push that to a separate platform. I want to push that to our logging platform. So I have up to 3 locations I want to push. And in the future, that may change. Logging might move to a new solution. So I don't want to be tightly coupled to anything. I want to be able to implement anything I need. When onResolve or onError are called, both are passed to the configuration and the context. The difference is one's given a decision, the other's given an error. Inside the decision is all the data related to the decision that happened. For example, there is an extra logs field that your adapter could be pushing extra logs into. Your adapter itself can also push logs, though. So you have multiple options here. Now, we're at JSConf. We're talking about framework-agnostic feature flags. So of course, for a moment, I'm going to talk to you about React. And the reason is that to provide a first-class developer experience in these other frameworks, a lot of these feature flag solutions tightly couple. So for example, the flags module we were just talking about. That tight coupling allows them to build a very tailored experience. We don't want to give up that developer experience, but we also need something that's framework-agnostic. So we build these other modules that work with these other frameworks to provide that tightly integrated experience. So if you're using this module with a React app, you would install those 2 pieces, and then you would get that great developer experience. These examples here are just to give an idea of what you can do. The actual implementation can be for anything. So you could write this for Angular or any other thing, Solid.js. First one is the server feature ramp component. This was inspired a little bit by the way that Rust match arms work. You provide a flag function, not the result. So you don't even resolve it. You just import the flag function, pass it through, and it now has a typing knowing, here's every prop I need to define. Every prop needs to return something that can be rendered. If I fill in part of it but don't complete it, we can see I have an error. This makes sure that you clean up this component and define any new experiments. So if I added a new treatment, I would get a TypeScript error, and I would not be able to pass the PR. If I deleted a treatment, same thing. Once we add that final treatment, everything's passing the build now. Sometimes we do have to give feature flags to the client. We do everything we can to avoid that. We want to prioritize server-side rendering. We want to prioritize sending the minimal bundle to the client. But there is some complex logic that's just necessary to have client feature flag data. And for that, in React, we created an SSR feature flags provider. This is specifically for a React SSR application. And you can pass in multiple feature flag functions. Again, we do not resolve them. We just pass the functions in. We then give it children, which is what we want to render. Internally, this suspends the children. In parallel, resolves every feature flag, injects them into a React context. And now the children inside of this can use that context to consume the feature flags. We suspended because we have to resolve all flags before we can return this to the client. So this you do not want to use unless you absolutely have to, since you're doing something blocking to the client. Now, in most React frameworks, you can do things like loading skeletons and stuff. I'm not going to get into that because that's not what this talk's about. Now, another utility we built, not even specific to React, but commonly seen in SSR apps, is resolving multiple flags. So this is a pattern we started to see. It's not terrible. I don't love it either, though. You know, we got this different naming going on. Some teams formed up where they started doing really consistent naming, but only in their part of the application, their pages. And then other teams were doing other naming. Again, that's not end of the world, right? But what happens when product asks us to add dark mode to the application? So we add dark mode. Does anyone notice what we just did? We broke all the feature flags because of the ordering. This is very easy to do, not just by adding something to each end, but even just moving the variables or moving the functions on the bottom. So if someone just comes in here and says, I want these like sorted alphabetically or something. So we built a method that helps with this called resolve flags. Resolve flags takes in an object, again, of functions not resolved, but it returns an object of strongly typed resolved functions. It runs them all in parallel. It's almost identical to the last slide, actually, but we've created structure here where somebody can't easily break something by just moving around a function call or variable destructure. The result is actually strongly typed. So in your editor, when you start to type dark mode, you'll see autocomplete that says dark mode result. And if you typed something else, like is dark mode, you're going to get a TypeScript error. DevTools. So we need to be able to provide a great experience for developers to not only test their flags, but also work on their code. And so they need to be able to toggle themselves into an experiment and continue to write code on their local. But we also want to extend these dev tools to more than developers. So maybe they're not dev tools anymore. We want product. We want design. Anybody at PayPal. And technically, since dev tools themselves are built on flags, we can target IP addresses. We could target user account IDs. We could target anything. And we can expose these dev tools if we want outside of the company, even on the public-facing prod. So we could let a product person use their cell phone and actually experience a UI feature ahead of time. This is a quick example of the dev tools, and we're actually going to be showing an example of that pay in full tile bouncing, and it's a failed experiment, I believe. I believe this experiment doesn't even exist anymore. And this is a great example because it's very often we write a lot of experiments real fast to test things, and a bunch don't succeed. So we don't want to spend a lot of time doing that, and that's what this is optimized for. So we're going to move the mouse up to the top, open our feature flag DevTools, search for our flag, toggle the state, and we do reload page because it's an SSR application, and we see that it bounced. These dev tools are specifically built in React. They're even using checkout components. So these are not exported even internally for other teams right now. It's not the ideal state we want to be in, but this was something we built while we were building the module. The next phase would be building something that's a little more reusable, for example, like a browser extension, because these feature flags can be used even in API servers, not just web frameworks. So along the way, we learned quite a few issues and lessons, And the biggest one would be how complex feature flags get real quickly. It's very easy to end up in a state where you have lots of different filters that need to be passed. You have complex allocations, and we could have multiple treatments and allocations within the treatments. And what I mean by that is we may have an allocation for US and an allocation for Canada, and they're at different ramps. When that resolves, in the code, all I care about is what treatment you're in. But when it comes to analytics and logging and debugging, I care about what allocation you're in as well. I need to know, did you go into the 10% of users from Canada? Otherwise, I can't create good reports on those users specific to Canada. The AST parsing, that was an interesting one because it was really complex to create our adapters in the beginning. We heavily relied on AST for every single adapter built, which meant we had to walk the AST, look for what we need out of the config, do some code generation. But in reality, most adapters care about nothing more than a simple config object. So the AST will now still be parsed and passed to the adapter, but the adapter will also get a passed config object, which is a plain JavaScript object. So if all you care about is some string values in an object, you can write an adapter without touching AST. You could just write some plain old JavaScript and go. Architectural decisions and trade-offs. The big one really is that being framework agnostic means we can't provide batteries included out of the box. So that means your logging, your data sources, and your framework kind of couplings or tight integrations, like those React things I showed. We can't give those to you in the core module. But that's why we have these other modules you install. So the core module focuses on just the basics. And it focuses on things I can do across all different frameworks, all different runtimes. Majority of that code is actually typings and code generation. It's focused on how do I build configurations that these additional enhancing modules can utilize. So they can create that experience that you would feel out of a tightly coupled feature flag system. So you can move between any logging solutions you want. You can move between any data sources you want, launch darkly to post hog, doesn't matter. And you can move between frameworks. What's next? Well, we're collaborating more with the Flags SDK team. Originally, the plan was this module would already be published in Gem by the time I gave this talk. But we're collaborating with them to try to merge our core module together with them, so that way we don't duplicate this flag definition process in the ecosystem. And then we will focus on building and publishing our utilities as open source. So you can consume the core module and then utilize our utilities for your code generation and framework-specific integrations. We're also currently testing the idea of generating source code. Not everybody loves that idea, but we're testing where we generate actual feature flag functions directly off experimentation platforms. So for example, you have a new checkout experiment defined in something like Launch Darkly. Once you run code generation, you can directly just import this is new checkout and call the function. That function would know all the definitions from Launch Darkly. So if Launch Darkly needs filters, it should already have that strongly typed on it and say, hey, you need to pass me this specific data to do these filters. And that's it. So if you're interested in learning more or following along when this gets released, feel free to follow me, or just keep an eye out for also the core flags module on NPM, because that's where it should land. Thanks.